Correlation. Correlation refers to the relationship between two variables or two sets of data. Now, there's generally three types of ways we could get correlation. So this first one here is a positive correlation, right, when it's going up. So if you see your data here and you can kind of make a line that goes straight up or goes up, then it's positive correlation. Likewise, if you can make a line that's going down for the most part, negative correlation. If you really can't make any lines, it's kind of all over the place, no correlation. Right, it just shows you the relationship between two sets of data. Like for a positive one, this could have been, I don't know, temperature and then electricity bill, because you'll be running the air conditioning all day, right? As temperature goes up, electricity bill goes up. It's a positive correlation. A negative correlation would be something like, I don't know, temperature and the sale of sweaters. Right, as temperature goes up, people probably buy less sweaters. And then over here, when you have no correlation, I don't know, it could be anything. It could be temperature and sale of gas or something. Where it's just like, no, it doesn't matter. You're going to need to buy gas no matter what. So, stuff like that. Now, there's actually two types of correlation. And like when we're talking about what type of data we get, it could be a linear data. So that means you can make a straight line out of it. You could use like a y equals mx plus b formula. Or it could be nonlinear, right? You see how it kind of curves up there? That'd be a little more complicated. So, linear, nonlinear. Now, this correlation could also have, we could also talk about how strong it is. So, like if you look at the first one here, you see how like all the data is kind of going up, it's all kind of close together. There's a very small standard deviation. Well, that's going to be a strong positive correlation. Over here, you see the data is a little more scattered, moderate. Then over here, it's still kind of going up. It looks like it might be none, but it's actually kind of trending up, but it's really weak. Same thing for negative, right? Going down, kind of a straight line. Going down, but a little further off, and then going down, but way further off. So correlation can have different strengths, positive and negative. And lastly, there could be outliers, right? So if you see this data here, now notice how when you connect the line here, it's going to eventually connect to this line down here, which is the way from that data, but it still kind of fits within the same path. So that's not an outlier. However, this number right here, like that's really outside the other data set. So you consider that an outlier. Let's talk more about correlation. So correlation actually has a coefficient, so it tells you the actual value at which, how closely related the particles are, and that coefficient is R. Now, R ranges anywhere between -1 and +1. -1 being a perfect negative correlation, so like a straight line going down. That's my attempt at a straight line. And +1 being a perfect positive correlation. Straight line going up. Right, so as you can see, positive value means going up. It's a positive value. Negative value means it's a negative correlation. That's what I meant to say. And all these things here are all good stuff, right? Positive value is positive. Negative value is negative correlated. The size of the R tells you how strong it is, right? Closer to 1 you are, the stronger you are. So closer to +1, the stronger you are to positive correlation. Closer you are to -1, the stronger negative correlation you are. If you're close to 0, that means you're going to be very weak in either direction. And in general, we have this big old chart here. It tells you all the different correlations. So you see down here, 0.1, no correlation. Now, a good thing you don't have to memorize this. The key thing to know is like kind of the idea. Like, oh, if it's a perfect 1 either direction, then it should be perfect, straight line. Now, if it's between like these values, 8.7, 9.5, it's a strong positive correlation or strong negative correlation. And then there's if it's below that, it's moderate. Above that's very strong. Like, and anything below 0.5 is weak. You don't have to have this memorized, but you want a good sense of what the values are. So if you see like a 0.9, you know, oh, it's a strong positive correlation. But that's what this is. So those are your correlation values. Again, don't even have them memorized, but you want to have a good sense of, if I give you like 0.75, like, oh, it's a moderate correlation. If I give you 1, that's perfect. Now let's do an example of how to use this. Now the first thing we want to know is that we're going to do this on the calculator. So I'm never going to ask you to find R without a calculator. It's just solely going to be a calculator. So this is this problem. Joe hangs her clothes out to dry every Saturday and notices that the clothes dry more quickly some days than others. She investigates the relationship between the temperature and times her clothes take to dry. So here we have nice Celsius temperature, and then our Y is how long it takes for it to dry. So you want me to draw a scatter plot. You can do this by hand if you want, but I want to show you how to do this on the calculator also. I'm going to calculate R. only ever going to do on a calculator, and then we're going to use the information we get to describe temperature and time. So let me bring up my calculator. Let's clear some of my data from previous stuff. So stat, edit. Let's clear my values here. Type in the data that we have, 25, 32, 27, 39, 35, 24, 30, 36, 29, 35. And then type in your Y values, 100, 25, 38, 105, 70, 35, 75, and 40. Now, this is going to be a little different than we did before. So before we get done figuring out the one variable stats, that's not the case this time. First, let's draw a scatter plot. Now, the way we do that is we do stat plot. Put this over here so I don't need the data anymore. So go second, stat plot. I'm going to turn on our plot. Turn it on. Now we're going to scroll down to the type. Now, see all these types? I had it from an earlier video of doing a box whisker plot. Let's go over here to the stat plot, the original one. L1, L2, all good. All the rest is fine. Hit graph. Now again, you don't see the data again because it's still the window's off. So we got to fix that. Easiest way to do this is put zoom 9, zoom stat. And it gives you a nice little stat plot right there. So that's what our data looks like. I'm going to try my best to copy this on our thing here. I'm going to remember it was kind of like this. Right? By the way, that looks like a mapping outlier right there. Now they want us to calculate R. So a couple key things about calculating R. You want to go to mode. And you want to go to the very, very bottom and make sure your stat diagnostics is on. For some reason, the default's off. Turn that thing on. So keep that in mind. If you want to calculate R, you have to have a stat diagnostic on. That's under mode. Alright, so go to mode, turn it on. Once you actually hit enter, some people always forget to hit enter. You could quit. Now let's go back to stat, calculate. We're going to go to linear regression number 4 right here. Very important. So let me write that down. Make sure we go to stat, calculate, and then you go to linear regression. Number 4. Now, x1 is the x-list is L1, y-list is L2. Now notice in this case, I don't have a frequency list, right? This isn't a frequency list about how many times 25 happens. So we're going to blank. Sometimes we will need that, but in this case, no frequency list. Store request, we'll talk about that later. I don't need to do that. Just go to calculate. What it does is it finds a nice equation. We'll talk more about this in the next video. But here's the key. They give you the R right there. R is negative 0.941. That's our correlation coefficient, negative 0.941. And then finally, describe the correlation between temperature and drying time. Right, look at that, it's a strong negative correlation. It's actually very strong. It's like a 9 something, so very strong negative. And that's all IB wants. They want to say if it's positive or negative, and they want to see if it's strong, very strong, moderate, blah, 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 blah. Right, so remember, the closer you are to 1, the stronger it gets. Anything above 87 is 87 to 0.75 is like strong. Above that's very strong, below that's moderate. And that's the idea.